This is project 3, video number 3, the one where we do the documentation and finishing touches. So let's see up here. I put function, no, percent function mag dipole force. And you want to thoroughly describe what it does in a way that it doesn't require the reader to have access to the project handout to know what's going on. So you got to say, for the case of a particle having a magnetic dipole moment that is at the origin of a Cartesian coordinate system and has magnetic dipole, the magnitude of the magnetic dipole, for which the magnitude of the magnetic dipole is mu1. This function calculates the force that the magnetic field of that magnetic dipole is going to be exerting on a particle that has magnetic dipole moment mu2 and is at position x comma y on the same xy coordinate system, and with its magnetic dipole moment oriented at angle theta relative to the positive x direction. Words to that effect, only clearer. I was trying to describe it without, write down those words and then rearrange them into well-articulated sentences. And then make sure you've got input variables. So it would be these 5 input variables. So explain what function, what it does, and then and you got to have your name in there. So by Jeffrey Schnick. And then I go with input variables. And you'll have find the 4 input variables and then output variables. That actually worked, that pound sign, but I'll be consistent here. Define the so input to this function are the arguments of the function, these guys, and then output to whatever function is calling this one, or to the command window. In our case, if we're just calling it from the command window, it'll be these 2 variables, the force and the angle of the force. Attribution. Tell me a story here. Let me know where you got stuck, what you really needed my help for. I think you should be able to do it all by this time, although I gotta admit the algebra in here gets pretty sticky in the calculus, just taking derivatives, but it's, you got, at some point you got the product rule, and with one of the factors you got the chain rule, so it's not trivial, but you should be able to do it, and maybe if you make some mistakes you can catch them on mine. If I made a mistake, make sure somebody catches it, please. But I think it looks pretty good based on the way it was the code was working. So I think for this I think I'll say the following. A and B were created to simplify the expressions for the force components. So they don't really have any particular meaning by themselves. I got to explain a little bit about what's going on with the code. And then I think that's enough. Explaining, I'll go ahead and save that, but I want to use the checklist that we're provided with, make sure I didn't miss anything. So, complete algebraic solution with diagrams. Did have at least one diagram. Each function an outline of the steps. I had that. Program, reasonable attempt. Surely did that. 1.m file. That's all we got this time. I think it works properly. No extra stuff being printed. I'll check it a couple more times just to make sure after I did the documentation that I didn't mess it up. Name, I put my name in it. I remember doing that. A comment, I didn't really do that, but I started it and told you that you had to. The input variables, or list of arguments. The output variables or return variables, we had two of them. I once again, for both of these, B and C, I didn't actually do it, but I addressed that, and especially the fact that you have to do it. I felt the A and the B, somebody that didn't have access to my pencil and paper part, they would be wondering what the heck that was, so give a little bit of information on that without going overboard. No graphs and attribution. So make it clear what you were are able to do by yourself, and what you needed help with. And I think the attribution was the last thing. Make sure your attribution is not identical to mine. So in mine I used the help and on ATN 2D. That turned out to be perfect. Just a D after the ATN 2. That one I don't think I knew. It popped up. Alright, I'm going to save it. Run it. Still getting the same thing that I was before. Run it with a semicolon, make sure it gives nothing back. Yeah, but I prefer it where I can see it for testing purposes. So actually, I don't think I need to say that again, but I'm going to call that a wrap on project 3, video number 3, the one in which we do the documentation and finishing touches.